everyone, in this video we'll be discussing about how to calculate the capacitance when the capacitors are combined in both series and parallel configurations. First of all, we need to look on how to identify if capacitors are arranged in series or parallel. If the capacitors are arranged in series, there is only one way for the current to flow. So my conventional current comes out of my positive terminal and travels around. While if my capacitors are arranged in parallel, our current will also flow from positive terminal, but now the current have choice to either go through the first capacitor and get back to the negative terminal, or it can keep flowing. In other way, we also can tell if the capacitors are in series or parallel by looking at their starting and end parts. If they are connected in series, end of the first capacitor will connect with starting of second capacitor. If they are in parallel, both starts and ends of capacitors are connected together. So, in this example, we are going to figure out the equivalent capacitance in combination circuit that consists of two capacitors that are in parallel to each other, and those two are in series with the third capacitor. For the total capacitance, we have to work on all three of these. When we have capacitors in parallel, we can just add up their capacitance to get the total capacitance. So, we have the capacitance of capacitor 1 and 2 equal to 7 microfarads. Then, we can redraw the circuit into this. Now, we have all the capacitors connected in series. When we do capacitors in series, we have to use the 1 over equation. So, 1 over C equivalence equal to 1 over the capacitance of 1 and 2, which we just figured out was 7, plus 1 over C3, which we have is 1 over 5. It is important to remember that this number is not the total capacitance, it is 1 over the total. To get the answer, I have to take 1 over 0.343. So we have two-step process here. Firstly, do the two in parallel. Then take the third one and put it in series with the two we just did in parallel. And we get 2.9 microfarads. As easy as that.